application of midline theorem. So we are going to talk about the midline of the trapezoid. So what would happen? So it says we have learned that for the midline of the trapezoid, we know that the length of EF, that's number one, EF is, you add AB, length of AB, plus DC, and then divided by 2, you can find the length of EF. So that's the relationship between the midline and then the base 1 and the base 2. Another thing is that when we have the midpoint, the midline of the trapezoid guarantees, that segment guarantees to be parallel to AB and also DC, which is, this midline is guaranteed to be parallel to the base 1 and the base 2. All right, so let's look at an example. So let's say we have this trapezoid. Even though it doesn't look like a trapezoid, maybe many times trapezoid is, the base is horizontal, but this still is a trapezoid because, well, I claim that this guy is parallel to this guy, right? So that's the definition of trapezoid. At least, you have at least one other definition, at least one sides are parallel, which is a quadrilateral with one side parallel. So let's find out the midline right here. So it says right here that you add the base 1 and the base 2, which is 4 plus 5, and then divide by 2, that's going to be the length of midline. So 9 halves, or 4.5. So the length here is going to be 9 halves. How about this guy? So can we find the base 2 with the given information? So we know that this base 1, or base 2, whichever, one base plus this guy should be 6, right? So let's say we're going to have, let's call this whatever, x, right? So 2 plus x divided by 2, right? So you add this plus this divided by 2 should be 6. Right? And then you just do the basic algebra, multiply both sides by 2, and then subtract both sides from 2, then you get 10. So x should be equal to 10. Sorry, I gotta pick up phone.